Unit circle. By this we mean a circle whose center is at the origin and whose radius is 1. So let me draw my coordinate axis. So this is x-axis, y-axis. Its center is 0, 0 and radius is 1. We measure the angle with respect to the positive x-axis. So for positive x-axis itself, we say that this is theta equals 0 degrees. And every counterclockwise rotation is considered as a positive angle. So counterclockwise, meaning going this way, is positive, whereas clockwise rotations are considered negative. So clockwise go this way. These are considered negative. So if there is an angle in the first quadrant with respect to, we measure with respect to the positive x-axis. So if this would have to happen after a counterclockwise rotation. If this is theta, then this particular angle, which is in the fourth quadrant, that has the same magnitude as the one in the first quadrant, but it's in the fourth quadrant. Since it's clockwise rotation, this angle would be considered negative theta. And let's say this point has coordinates x comma y. Now we can define our trig functions sine, cos, tan in terms of the coordinates of the point on the unit circle. How are those defined? Sine theta is defined as the y coordinate and cos theta is defined as the x coordinate and tan theta is the ratio y over x. If you remember your SOHCAHTOA, you used ratios of sides of triangle. But for those definitions to work, theta would have to be acute. But now, theta does not have to be acute. It can go past 90 and it can actually go past 360. It can get as big as you want. And it can also be negative. It can be negative something and it can be as large negative as possible. So the domain for your function, for trig functions now is everything between negative infinity and infinity. So this definition includes all the previous SOHCAHTOA definition, but it has more. So you can think of this as an extension of SOHCAHTOA. Now, let's go ahead and redraw unit circle. This time I'm going to draw a little bit bigger. Because I'm interested in getting the coordinates of some points on the unit circle. We already know 4 points where the circle meets the axis. So this point, that corresponds to theta equals 0 degrees. And we know this is 1, 0. And this corresponds to theta equals 90 degrees because you would have to rotate 90 degrees in the counterclockwise direction to get there. And the coordinates up on top are 0, 1. Similarly, the coordinates here, let's go ahead and first write down theta equals 180 degrees here. And the coordinates are negative 1, 0. And down below, this corresponds to theta equals 270 degrees. And the coordinates are 0, negative 1. Now, how did we define the trig functions? Sine theta is y, cos theta is x, and tan theta is y over x. So if I want to know what sine 0 is, I just have to look at the y coordinate of this point on the unit circle. So sine 0 is just 0, and cos 0 is 1, and tan 0 is 0 over 1. So I can get the trig functions for sine, cos, tan for 0 degrees. It would be nice if I can get for more angles. And if you can remember just one number, one fraction, and that would be square root 2 over 2, then you can get 4 more points on the unit circle. So I would like to think of this as east, north, west, and south directions. Now I can draw lines that cut in the middle. They are equally inclined. So this is going in the northeast southwest direction, and I'm using this green color. And similarly, you would go in the northwest and southeast directions. And let's go ahead and write down the angle measures. This is exactly in the middle of 0 and 90. So this corresponds to 45 degrees. And this is in the middle of 90 and 180. So this would be 135 degrees. This one is in the middle of 180 and 270. So that would be 225 degrees. And this one is then 315 degrees. And these 4 points, they have both coordinates have the same magnitude, root 2 over 2. So let's go ahead and write down root 2 over 2, root 2 over 2 everywhere for all these 4 points. And we will supply the negative signs later on. So let's focus on the magnitude for the time being. So this is root 2 over 2, root 2 over 2, and that point also has root 2 over 2, root 2 over 2. So these are the magnitudes, and I know second quadrant x has to be negative, but y is positive. So that makes these 2 points have different coordinates. In the third, they both are negative. So negative root 2 over 2, negative root 2 over 2. In the fourth quadrant, you have just that. Now, with these 4 additional points, we can find the trig functions for 4 more angles: 45, 135, 225, and 315. So what is sine 45 degrees? Well, sine is the y coordinate, so it's root 2 over 2. And what is cos 45 degrees? That's also root 2 over 2. And if you want tan 45 degrees, you just divide. But they are the same fraction, so when you divide, you get 1. Similarly, what is cos 135 degrees? That would be the x coordinate, negative root 2 over 2. So we go back to our definitions. Sine was y, cosine was x, and tan is sine over cosine, which is y over x. So just knowing this one fraction, root 2 over 2, we could get 4 more points on the unit circle. Now what is also easier is if you go 15 degrees on either side of these new directions that we just obtained. So 15 degrees, if I come closer to the x-axis, and I'm using blue color this time. So this corresponds to 30 degrees. And similarly, let me extend this line. So here I would have This is 15 degrees on that side, so it would be 210 degrees. Now let me get here as well. So we are coming closer to the x-axis by 15 degrees. So what would this be? This is 135 plus 50. So that is 150 degrees. And this angle would be 315 plus 15, which is 330 degrees. Okay. Yeah, these 4 points are again not too difficult. And also, let me go 15 degrees on the other side of the green ray. So this is going in this direction, and let's extend that. So this red line is staying closer to the y-axis because the green line was equally inclined to both x and y-axis. But the red is closer to the y-axis. This is 16 degrees. We have gone 15 degrees on that side. And this would be, it has come closer to the y-axis, so it's more than 225. It's 240 degrees. And similarly, let's go ahead and draw the line closer to the y-axis going in the second and fourth quadrants. So you have this line that goes in the second and fourth quadrants. So this one is closer to the y-axis, so it's 120 degrees because you're going clockwise from 135. And this one would be 315 minus 15, so that's 300 degrees. Okay, so now what I'm going to say, I wanted to do these 8 points at the same time because we will first learn about 2 more fractions. And what I want to say is 1/2 and root 3 over 2. There are these 2 fractions that appear in the unit circle. And what we want is their relative sizes. 1/2, we all know it's 0.5. Root 3 over 2 is irrational and it's about 0.866. So definitely root 3 over 2 is bigger than half, and that's what we want to know. So root 3 over 2 is bigger than half. And the coordinates on this, the blue and the red lines, are going to be just those numbers. But if the point is closer to the x-axis, so here the green arrow has moved closer to the x-axis, which means the x-coordinate will be more. So I'm going to write the bigger fraction first, smaller fraction next. Similarly, let me fill up this one. This is also closer to the x-axis. So I'll first take care of the magnitudes. X should be more, y should be less. Here also x should be more, y should be less. And here x should be more and y should be less. So root 3 over 2 and half. And now we will supply the negatives wherever they are needed. In the second quadrant, x has to be negative. In the third quadrant, they are both negative, both x and y. In the fourth quadrant, it's just the x which is negative, but x is positive and y is negative. So that's what I have in the fourth quadrant. And similarly, I can get these red points. So this time It's y which is going to be bigger because this point is closer to the y-axis. We have rotated this green arrow closer to the y-axis in the direction of y. So let me write down y has to be big, so root 3 over 2 there and half. Here also let's go ahead and do that, 1 half root 3 over 2. Y has to be bigger, so this one is 1 half root 3 over 2, and this one is 1 half root 3 over 2, and time to supply the missing negatives. Second quadrant, x negative, y positive. Third quadrant, both x and y are negative. Fourth quadrant is x positive, y negative. And that's our complete unit circle. So it only has three fractions really, root 2 over 2, 1 half, and root 3 over 2. In the northeast, northwest, southeast, southwest directions, they're all root 2 over 2s, but you just have to supply the negatives wherever they are needed. And for the other angles, which are not in those northeast, northwest, southeast, southeast directions, you just have to figure out, is it closer to the x-axis or closer to the y-axis? And the one that's closer to the x-axis would have higher x-coordinate, like this point, 30 degrees, or 150 degrees. It would have greater x-coordinate in magnitude. And then you supply the negatives. And that's it. So this should tell you your trig functions for now 16 angles. So for example, what is sine 60 degrees? It's root 3 over 2 because the y coordinate is root 3 over 2. What about tan of 315 degrees? So this is green and 315 was in the middle. So it's negative root 2 over 2 divided by root 2 over 2. So that's negative 1. What about cosine of 210 degrees? For cosine, I will look at the x coordinate and so on. So that's the unit circle, and hope you learned something. I guess there are no practice problems for this video. Happy learning, and I'll see you in another video. Thank you.